We are recording. Great. So today we'll be discussing the last uh, parts in probability, and we'll be trying to see how to. We'll do a little bit more later on as well. We'll be doing Markov chains and so on a little bit later in the course because we'll be doing reinforcement learning and Markov chains are a part of it. Uh, but today we'll be completing all the fundamentals of probability and statistics that you would be needing to solve any understand any algorithm in reinforcement learning. And mostly it will cover most of the basics, and you can go back and read or study the last time's sessions into you want to know more about probability and stats. So today I'll be discussing more about I'll be discussing about joint distribution, conditional distributions, and conditional expectations. So these are not trivial concepts. Please feel free to stop me and ask me every time there's a question. So I'll get started with this recap. I hope you remember what is a random variable. A random variable was a map from the sample space to the real number line. And when I say something, I ask what, you can always intervene and answer the question as well if you are willing to get your voice heard as well. So this is the mapping from the sample space to the real number line. We saw this, and we also saw, so, this is my sample space, an event or an element of the sample space, you just plot it on the real number line is a random variable. So now what did we see? We saw that if x belongs to a set of values a to b. So what does it actually mean? If x belongs to the probability function, first of all, is defined on what? The probability function is defined on. So recall, we had the sample space, the event space, which had subsets of the sample space, and the probability function. So the probability function is defined on, from where to where is the probability function defined on? The probability, does anyone remember? The
Like from
probability,
real one,
uh, the
when
sample,
space to 0 to 1.
yeah, okay, correct, right, very good. So just taking a random variable between two values again does not work. So we will have to put it in terms of events. So I'm just reiterating these things so that you get a very good hang of things, because set theory is very easy, but as soon as you get into probability and random variable, they become murky. And if you do not remember the basics, you would be just doing calculations, which I don't want you to do. You should be able to visualize every step that you're doing. So if a random variable is between A and B, what does it mean? Conceptually, I don't want you to write it in terms of maths. Can anyone tell me what does it mean? Whose probability do we want to find? We want to find the probability that of that event, say the event E, which belongs to the event space, such that E is, say E belongs to the event space. So let us write EAB. So can you tell me what is EAB going to be? EAB will be,
EAB is like mapped to AB by random variable X.
yes, it's a map between A and B. So there will be a pre-image of the entire set on the event space, right? A subset of, so this will be, E would be a subset or would belong to the event space, not a subset, sorry, would belong to the event space. So it is all the samples omega that belong to the sample space such that X of omega belongs to A and B. So it's like, say, head, and so you say, for example, a coin toss. If I toss a coin and tell you that X is between 0 and 0.5, what is the event for the Bernoulli random variable that I am referring to? What will I get? Whose probability will we find? So if I say that X is Bernoulli random variable, Bernoulli P, that is x can be 0 or 1, and x, the probability of x belonging to 0 to half. Can you tell me what will this be? Which is this element?
For which f of x is equal to 0.
Yes, this is the probability of that event such that x of omega is equal to 0. That because Bernoulli random variable can either be between 0 and 1, so only 0 is the event that I consider. So this is just going to be x inverse of 0. So x inverse of 0, this is the inverse map, recall. So x inverse of 0 is the tail, right? So if it was a coin toss, then if it can be half or whatever, if it is for a unbiased coin. So this is what is a recap of whatever we had done till now. But now, if there are multiple random variables involved, what will you do? So there can be situations in this world, for example, audio and video I'm speaking to. I am speaking to you, that may be a random variable, what distribution I'm talking about. The video itself has samples from that random variable. But I'm also speaking to you in audio. So there is a link between the video and the audio. So this is known as when you have a joint distribution. So when you have a joint distribution, you have links between multiple random variables, which refer to the same, probably some same events in the same sample space. So let us try to understand what is it. So we'll understand the PMF of a joint first. So P of x, say we'll start with 2. You can look at this definition later on. X2 is equal to small x2, or let us write a comma b for your understanding. This is the joint. Okay. So my question to you is, what does this mean? This means that it is all those events, I'm writing it down, all those events such that x1 of omega is equal to a and x2 of omega equal to b. So in set theory notation, how can I write this? Can anyone tell me? All those events such that x1 of omega is equal to a and x2 of omega is equal to b. In set theory notation, I can write this as omega belonging to the sample space such that x1 of omega equal to a, comma, x2 of omega equal to b, right? Which is equal to omega belongs to omega, x1 of omega equal to a, intersection omega belongs to omega, x2 of omega belongs to a, b. Is this clear to everyone? Fine. Is this fine to everyone? So if both these events have to occur, for example, I write a statement and also say something. If both of them have to occur, they have to refer to some events in the space. So for example, we'll get to an example, but yeah, is this clear? So both the events x1 of omega has to be equal to a and x2 of omega has to be equal to b, because these are the two things that must satisfy. So this is equal to, this can be written as, this I'll be using more often in the rest of the day. So I'm writing it again. X inverse A intersection X inverse of B. Any questions? So it's like all the events must occur, whatever whatever each of the random variables are constraining it to be. For example, A and B over here. So if there are n number of data points, so it should be the intersection of all of them, all of those events from those random variables. Is there any question? If there is none, I'll go to a sample solution, and then we'll see. We'll wait for a minute. Any questions? Okay, either everything is clear or nothing is clear. I told you this is not trivial. In case you are finding it difficult, please stop me because I can't see you all. Okay, so now say we have two Bernoulli random variables. So if there are two Bernoulli random variables, can anyone tell me what are the possible outputs that you can have? So Bernoulli random variables are 0 or 1. So let us write it down. Two Bernoulli random variables. Random variables. Fine. Now if I have two random variables, x1 and x2, I think I wrote x and y. So what are the values that this combination can take, x comma y?
0, 0, 0, 1, 1, 0, 1.
Very good. 0, 0, 0, 1, 1, 0, 1, 1. So these are the values it can take. So because these can belongs to either 0 comma 1 and this belongs to 0 comma 1. So x comma y belongs to the Cartesian product of 0 comma 1. Fine. Good. Very nice. So now I say I give you all these probabilities of each of them happening. So for example, 0, 0 is 1 by 4, 0, 1, 1, 0 is 1 by 8, 1, 0, 1, 0 is 1 by 4, and 3 by 8 respectively. So these are the four events that I have given you all the probabilities. It's written on the left side, x0, y0 is equal to 1 by 4, x equal to 1, y equal to 0 is 1 by 8, and so on. So these are not, we'll see, these are not typical events. These are not like two coin tosses. So independent coin tosses, which we'll come to. But these are more, they're dependent on one another. We'll see why. But first question comes to what is the probability that say x is equal to 0, just x is equal to 0, or just probability of y equal to 1. What are these probabilities? This is known as the marginal distribution. When I remove one random variable and keep the others, because this will become very important in our next anything you do, be it machine learning, be it reinforcement learning, because this is how we generally introduce new random variables. That is, we find out their marginals. But fine. So let us try to find out, how do you find out P of x? P of x. I have been given P of x comma y to me. So if I just have to find P of x, what do I do? So let us take P of x is equal to some k. What does it mean? It means that P x inverse k. Yes or no? This is fine. We have derived it 10 times now. This is the event such that the pre-image is, so it's the pre-image of the k, some element, omega or E belongs to the event space. Fine. So now I have to introduce a y. That's what I'm trying to say. So if I introduce a y, can I write this as x inverse of k intersection of omega? Can I write this? Right? The omega is the entire set. Intersection with any set A will just be A. Yes or no? Fine. Because this is omega.
Yes.
Okay. So now can I write this as probability of x inverse? So think this is a discrete random variable we did in class. So only k, discrete k's are available to us. Similarly, you can extend it to continuous, not a problem. So intersection, this omega, can you write this using something? Another random variable? Can we write this as some other random variable? I think we did it. We can write it in terms of a partition. Can we write this as omega as union of, for all k, x, y inverse of k? So for example, y equal to 0, y equal to 1, dot, 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 y equal to n. So whatever, if there are n outcomes possible, I take all of the outcomes and they are all mutually exclusive, yes or no? Because it's a random variable, again, is a function. So independent events have to map to separate outputs, right? So for example, head cannot map to both 0 and 1, right? It can only map to one of them, something like that. right? So I can write this as union of y inverse of k. Is there any question? Do you want any further explanation for this? Okay, so if that is the case, can I write this as, I just do use the distributed property of intersections and unions and write this as probability of x inverse k intersection of y inverse k union over all k. This is, let us use different notation. Sorry, let us use j over here. I understand there is a confusion. Right? This is over j. Because all the outputs of y we have to sum over. Fine. So now what theorem can we use? We have proved this in the first class. Do you agree these are mutually exclusive? What axiom of probability can we use? The union can be written as a summation of probability x inverse k, comma y inverse j. Yes or no? Fine.
Yes.
So what does this mean? It means, again, this can be in our colloquial notation. This can be written as x is equal to k intersection y equal to j, and you sum over all the j's. That's the output of y. So this is the law of total probability in random variables. So this is also called marginalizing. So given a joint distribution, so this is a joint distribution, joint PMF. If I want one of the random variables only, what do I have to do? What is the intuition? Can anyone tell me? If I want one of the random variables, I have to sum over all possible outcomes of the other random variable. So I'll write it down. If I want to remove a random variable from a joint, I have to sum over all the possible outcomes. Sure? So let us try and solve this question now. So now if I ask you what is going to be P of x is equal to 0, we'll just write it down fast. This is just for one, I'll write x is equal to 0 given y equal to and y equal to 0 plus probability x is equal to 0, comma y equal to 1. This is all we have to do, yes or no? This is 1 by 4 plus 1 by 4, that is half. Similarly, please fill out the rest of them. What is the probability that y x equal to 1? Again half, yes or no? I'm summing these two. What is the probability of y is equal to 0?
3 by 8.
3 by 8. And what is the probability y equal to 1? 5 by 8. Correct? Any questions? 0 is 1, 1 is half, 0 is 3 by 8, and 1 is 5 by 8. Fine, any questions? Okay, am I audible?
Yes.
Yes.
Okay, great. At least you are there in the call. Now, the question arises, are they independent or not? So remember this, I've written it on the left-hand side. When you revise, you can check it, but I'll prove it. What does it mean? So given two random variables, they are called independent if the individual probabilities, they product out. just in case, like this, for every x comma y. So for every values of the random joint distribution, they must product out. So first of all, let us use this and try to say if this above distribution, is it independent or not? Is it independent? Can anyone tell me? Then we'll prove it. So let's do no once. Why can't we do this? So probability of x is equal to 0 and y equal to 0. If they were independent, what would it be?
P of x of 0 into P of y of 0, which would have been
Good. So
3
left
by
hand
6.
side is okay. Left hand side is given to be 1 by 4, right? I remember. Yeah, this is left hand side is 1 by 4. And x of 0 is 3 by 8. Y of 0 is no, sorry. X of 0 is half and 3 by y of 0 is 3 by 8. Half into 3 by 8. That's what you said, right?
Yes.
So 3 by 16, which is not equal. No, they are not independent. So now, so this is an important lesson to learn over here. So for example, by chance it had become 4 by 16. Could we stop there and say that it was independent? If just by chance, if p of x equal to 0 and p of y equal to 0 turned out to be 1 by 4, could we conclude x and y to be independent? Can we conclude two random variables to be independent by just seeing two values, that is 0 comma 0? Can we? Any idea? Any intuitions? Anybody?
Was it
Okay.
required to check for other values also?
No, currently we have shown that they are not independent. But if it by chance became 1 by 4, we would have to check for all other combinations. That is x is equal to 0, y equal to 1, and so on, all four combinations. We'll see why. Is this clear? But counter example, 1 is sufficient because this is not already you have proved. It's like an AND operation. Already you have proved that one of them is not true. So the total thing is also not true. So let us understand formally what independence in terms of random variables mean. So two random variables are said to be independent if and only if all the pre-images of on the event space are independent. So try to remember what is independence of two events. Say A and B are two events. Then A intersection B is equal to A comma A into B, right? Independence of events. Yes or no? Two events are independent when the two events get product out. But for random variables, all the previous images, for example, independence means, say, let us take x is equal to I and y equal to j. Okay. So for this to be equal to probability of x is equal to I, probability y equal to j for all I comma j. That's the idea, right? For any value the random variable takes, this product must work out, right? Fine. So let us try to understand why. Can you tell me the left hand side? What is the left hand side going to be in terms of sets? We have already discussed it so many times. Anyone?
Probability of omega
Can we
belongs
write this as x inverse of I intersection y inverse of j? That's what we wrote in the first when we wrote a joint. Fine. So again, what are these? These are events, right? These are events in the so this was some event omega for which it mapped onto I. And this was some event E2, E1 and E2 which mapped onto J. So when I take Y inverse, I will get E2 and X inverse, I will get A1. That's the idea. So now I am saying that in this set of a setting, all these intersections must be equal to, for independence of random variables, for independence, all the events must be independent. All the events, pre-images, that is the events must be independent. So this can be written as X inverse of I into probability of Y inverse of J, which is same as probability of X equal to Y into probability Y equal to J. Is this fine to everyone? So for every I comma J, this should product out. That is the entire philosophy of this independence of random variable. Do you understand the difference between a random variable independence and the independence in terms of events? Just events? Good. So this is the end. This is a much stronger setting where all the like all combinations of pre-images, like 2 to the power omega time number of times. Fine. So now we understood, we have also solved the independence question. We have also understood what is independence. Fine. So now let us understand, once we have understood joint distribution, we have to understand what is conditional distribution. So first of all, try to recall what is probability of A given B. What does it mean? How did I intuit this, and how did I bring it in the class when I was referring to A and B as events? What did I say? I had said that it is the intersection of A and B divided by B. Yes or no? You remember that I drew an A and a B and I scaled down. So I said it has to belong to the intersection, since it means given that B has occurred, what is the probability that A has occurred? This is what I had said last time. So for the conditional distribution in terms of random variables, what do you think should be the definition? Can anyone tell me? Just say I will give you a extra easy thing. Say let us assume X equal to Y and Y equal to J. And now tell me, what should we do? Given that Y equal to J, which means the same thing, given Y equal to J, what is the probability that X is equal to I? So now in terms of events, how can I write this? Anyone? Because we will have to use this definition first in terms of events to get to the definition of a conditional distribution in terms of random variables, because we have till now used only for events, not for random variables. Anything? Any idea? So again, it's the same thing, right? X is equal to I means X inverse of I given Y inverse of J. So as soon as I write this, now these are events. And I can, as soon as I do that, I can write it as probability of X inverse of I intersection Y inverse of J divided by probability of Y inverse of J. Fine, which is same as probability of X is equal to I, comma Y equal to J by probability of Y equal to J. This is fine to everybody. Any question? We'll solve questions and it will become clear, but is the approach okay? So it's like the same thing, probability of x comma y given probability of y. So let us now find the conditional distribution of this Bernoulli random variable that we discussed just now. Can we find it? I'll just copy the diagram and bring it over here, or I'll just draw it. I'll just 1 by 4, 1 by 8, 1 by 4, 3 by 8. Could you just could any one of you just repeat me the table once? It'll be easy for me. 1 by 4. So this is 0, x value 0 and 1, and y equal to 0 and 1. So 1 by 4, 1 by 8, and
Again 1 by 4 and 3 by 8.
okay, fine. So again, P of the x, the marginal distributions we wrote half and half, and we wrote the marginal distribution of y as 3 by 8 and 5 by 8. Fine. Now I tell you to find out probability of x given y. So now tell me, if I ask you this question, what is the first probability that you will find? How will we go about it? So I have told you to find out P of x given y. So how many values will you get P of x given y for P of x given y? So is this just one number, two numbers, three numbers, four numbers, five numbers, and so on? So how will you describe the entire distribution P of x given y? So I just did it now. So x is equal to 0 given, say, y equal to 0. Similarly, like this, there will be how many combinations? So 4 of them. Right. So now if I ask you for x is equal to 0 given y equal to 0, what will it be? Again, yeah. Tell me. Yeah. Tell. I can't hear you, Antariksh.
It would be half.
Yes, that is fine. 1 by 4 by, this is 1 by 4, and this is half. Right. So similarly, so now if I ask you x equal to 1 given y equal to 0, do I really need to compute this? Or can I do some trick using law of total probability? 1 minus probability of x is equal to 0, y equal to 0. Right? This is your homework. Why is this true? So my homework to you is probability of x, say an event x is equal to k, given y equal to j is same as 1 minus probability of x not equal to k. Sorry for that computer science notation. Y equal to j. Right? So this is, I will write you to write it in terms of events and show it to me in the Teams. So this is going to be 1 minus half. That is half again. Fine. So similarly, we can find x is equal to 1 given y equal to 0. Oh, sorry, x equal to 1 given y equal to 1. What is this going to be? So this is probability of x is equal to 1, y equal to 1 by probability of y equal to 1. This is 3 by 8 by 5 by 8. That is 3 by 5. Similarly, probability of x is equal to 0 given y equal to 1 is equal to 1 minus 3 by 5. It's 2 by 5. So this is done. So we have understood joints. We have understood conditionals, distribution for random variables which are discrete in nature for the time being. So now we did it only using PMFs. Now as we get into the business end of things, we'll try to understand it for continuous distributions. And now I'll need your as a full little bit of support for doing this. For example, so for just a recall, that probability of x equal to x, just for a revision, and y equal to small y for all x comma y, what is this going to be? Can you tell me what it should be? So this is for the joint distribution. We have seen it for this example as well, and we have proved it as well. But yeah, just to keep in mind, what should this be?
1.
Yes, because you're marginalizing about across everything. This is 1. This is law of total probability again. Plus law of total probability plus the axiom that probability of certainty is 1. This is certainty because you are referring to all events by the intersection of x's and y's. If you're not convinced, please do this as well. I think I did it last time in the class, but yeah, fine. Now joint distribution in continuous random variables. So for continuous random variables, as we discussed last time, we do not have a PMF, but we have a density function or a PDF. So for the density function, again, should sum to 1, right? This is a trivial thing. There's any question, so because we did you remember that we said that a density function is, we intuited that a density function x comma y, sorry, in one variable into delta was the probability that x was approximately equal to small x, right? Because that was given in terms of this density function, as we had described last time, and we had found out the CDFs and we did derivatives and found out the PDFs back. So now, if I ask you similarly for a joint distribution, it will be again, what would be the probability that x less than x and y less than y? Can you tell me? I did it in the same way. So recall for a one variable, probability x less than x was defined as minus infinity to x fx of x, right? So now I ask you, if it is two random variables, what should it be? I am given the joint PDF. So what should be your intuition? What should be the integral? So it's between x is between minus infinity and x, y is between minus infinity and y. So what should it be in terms of the integral? It should be just minus infinity to x and minus infinity to y dy dx. It will be a double integral. If there are n random variables, it will be just n integrals like this. Is it clear? Is it fine? Okay, fine.
Yes.
So now if I tell you to find out f of xy from capital F of xy, can I do it in the same Newton-Leibniz theorem that we derived last time? If I take the derivative with respect to x, what will it be? It will be so I'll just so since y is not integrable over x, I'll take y inside and then I'll put x and y, x y dx dy, and then I say I have two different differentials. So this will turn out to be f of x y. I'll put the value of, so say x naught and y naught, let us put for the time being. So x naught comma y dy integral minus infinity to y ddy, which is equal to f of x y x naught y naught. This is what we wanted, right? So we can say that if there are n variables from the CDF to the PDF, you just have to take the derivative. If the derivative exists, the PDF exists, right? Otherwise, it may not exist, but the CDF always exists. Sorry, I forgot to put the 2. Now, what does independence again mean? We have already seen this before. So now we have seen it in terms of sets and everything. So let us now try to take it in terms of what would independence mean for CDFs and PDFs. We have seen for PMFs, right? So we saw P of x is equal to x. comma y equal to y was equal to p of x equal to x and y equal to y. This was for PMFs, PMF independent. Now I want you to find the how does PDFs or the distribution CDFs marginal line or product out 2. The CDFs product out 2 is also a thing to understand. So I have told you to prove that if they are independent, f of xy is same as f of x into f of y. So can anyone help me with this? How can I prove this? Please. First, tell me the definition of what is the CDF. It's fine. If you already know also, please help me out, right? Sometimes it's good to interact. Can I write this as x less than x and y less than y? So if this is true, so then what is this event and what is this event? Again, recall, this is all the outcomes in sample space such that x of omega less than x intersection with omega such that y of omega less than y. Fine. Yeah, tell me. So this is x inverse minus infinity to x intersection y inverse minus infinity to y. Right. So all the pre-images will be coming up over here. So now, if these are independent, what can I write? If two random variables are independent, all the pre-images are independent too. These events are independent. E1 and E2, which is same as probability of x inverse minus infinity to x, probability y inverse minus infinity to y. Is this fine? Which is probability of x less than x into probability of y less than y, which is f of x is x and f of y. Is this fine? I'll wait for a moment. If you have any questions, please ask.
দাদা
Any questions?
হ্যালো দাদা
Yeah, go ahead.
বলছি এটা ওই মানে E1 এবং E2 এরা দুজন মিউচুয়ালি ইন্ডিপেন্ডেন্ট, এটা কি করে করলে তুমি?
So that's what I was trying to say all this time. So so for two random variables to be independent, right? I said
হ্যাঁ
that that's what I was discussing in the PDF. So if you have a set, say E1, right? So they would map to some values on the number line, right? Say A and B. For A1 and B1. Similarly, I have another event E2, right? And that would also map to say some A2 and B2, right?
Yes, sir.
Fine. So now all I am saying is so these are being mapped by, so let me write it the same color, x and y is the other random variable. So I said that if you take a pre-image, right? So of this set, that's what we are doing. So I will just shade this part. So if I shade this part, I'll get E2 back, right? Similarly, if I take a pre-image of this A1, B1 set, I'll get E1 back. Fine. Now I say if x and y have to be independent, all E1 and E2 have to be independent. That is the definition of independence of random variables. Right? For every E1 and E2, for any E1 and E2 you choose, For any subset of the real number line, you take a pre-image between any two. That's why we saw, I was telling in the Bernoulli case, can I say for only one? I cannot say. I have to check all the combinations between two sets. Yeah, that's what I used. Yeah, good. This is how you must ask questions. Great. Now, let us do it the same thing for PDFs as well. So that is a density function. 1 is done, and 2. F of x, y, we have to prove as. Fine. So now I'll do it in the very similar way. How do I do it? Can you tell me? So what is this? So this x comma y, the joint distribution. What can I write this as?
As the derivative ddx fx.
That is a bit difficult to prove that way. I think I tried it last time, but I think there's an easier solution. That's fine. That you can still solve it. But there's a much easier solution. So do you remember the PDF's intuition? So do you remember, first of all, what would be x belongs to x plus delta between x and x plus delta? Limit delta tends to 0, and y belongs to y and y plus delta. Fine. This is okay. I can write this. I think it's no, I can write this. This. Do you agree? This is same as the integral between x and x plus delta f of x y xy dx dy and y plus delta. Yes or no? So now when I have a function like this, I am doing it in terms of these two deltas that I have. And since delta tends to 0, this function will remain same as the midpoint, yes or no? Or any of the edges? Correct? Do you agree? And I will just multiply this area just as I did in the 1D case. So this will turn out to be f of xy x comma y delta into delta. Yes or no? Any doubts? The left hand side? What is the right hand side going to be similarly? So again, what can I write? So this star, if x and y are independent, what can I write? If x and y are independent, they will product out, right? Similarly, as we did in the previous question.
fx fy into delta square.
Correct. This will also product out because they are independent. We saw all the pre-images will be independent. So this is the integral of f of x dx from x to x plus delta, and this is the integral of f of y dy from y to y plus delta. This is again f of x, f of y, delta square. So now LHS and RHS, I am seeing both are same because of these two. So I can clearly say f of xy is same as f of x into f of y. So everything products out. So your condition for being independent is either you product out the CDFs or you product out the PDFs. Okay, fine. So now let's do a question, a very nice question. So the first question says that it's a transformation of random variables plus it's a joint distribution. So can you tell me what can I? So you are told that z is x plus y. And both x and y are told to be IID random variables, IID exponential lambda variables, right? You are told to find the distribution of z or the PDF of z. How can we do it? Any help? So first of all, when there is a joint distribution and when there is a PDF that you need to find for continuous distributions, I would recommend it's always easy to find the CDF first and then take the derivative, because CDF always exists. So if I'm told to find the distribution of z, what can I write? What can I write this as? Yes or no? Fine. Is this okay? Which is same as probability of x plus y less than z. Now x and y are two random variables. I just can't use them directly, right? So if x increases, y has to decrease to keep it within z, right? Yes or no? Is that fine? So now I have two random variables. So if I have to find out the integral in this, so first of all, tell me, how does this area of importance look? Do you agree this looks like this? X plus y equal to z, everything here, and x and y is anyways greater than 0 because they are exponential. Exponential distributions are anyways greater than 0. So we were discussing the joint if z is between x and x plus y. So what will we try to do? So are you able to understand that this z has to be less than small z, means that the sum of this random variable x plus y must be less than that z as well. So the area, if this is x and this is y, this is only the area under which is of importance to me, which is what I'm trying to say to you. And now, but for what? So this may be an important area to me, but how do I get to the probability? Can anyone tell me? So if I have to find a probability or CDF, I can sort of start from PDFs, right? Yes or no? Can I start from PDFs? So first of all, what would be the joint of x comma y? Let's try to find that out. So again, I'll just copy this thing and keep it handy. Okay, I'll just rewrite it at the end. Fine. So x and y are exponential lambda random variables, and I'm telling you to find x plus y less than z, right? And I say that this is x plus y equal to z line, and this is the area that I need, or the integral that I need to calculate. Fine. Tell me now. First of all, if x increases, to keep a constant z, y has to decrease. Is that intuition clear? For example, you see, go towards the right, the y values decrease. So now, tell me what is the joint distribution of x comma y? Can anyone tell me? These are independent IID random variables. So what can I write this as? I proved it just now. The joint can be
0
written
to
as,
z, 0 to z, fx, fy.
I can write this as the product of the individuals. Fine. This is lambda e to the power minus lambda x, lambda e to the power minus lambda y. This is the distribution of any exponential distributions. We saw it last day. So this is lambda square e to the power minus lambda. So let's keep it here. So since these are independent, already told, so I can find it since independent. I product them out. For the joint. So now I am asking you, I have to find out. So now I know the joint distribution. I have to find out for this joint. This is the joint for Z also, probably f of Z. So p of x comma y, not the Z directly, but yeah, I have to find out what is the probability that x and y sum to something less than Z. So do you agree that is the joints integral. That's the feasible set, dx and dy. So between what can x lie between? Do you agree that y has to be less than z minus x? Yes or no? Since x plus y is less than z. So if x goes from 0 to x or 0 to z here for sorry, so what will y go between? Y will go between 0 and I'm just trying to integrate over this area. That's all I'm trying. So for a particular value of y, for a particular value of x, this is just z minus x. Good. So now I just put the value of the integral and try to find it out. So lambda e to the power minus lambda x. So y is independent of y, the first integral. Sorry, I should reorder the integrals because y is the integrand first. Yeah. Lambda e to the power minus lambda x dx. So can you tell me what would be the value of the inner integral? So we have already found the CDF for the exponential. It is 1 minus e to the power minus lambda z minus x. Yes or no? Just calculate the integral. It will be that. We have done it last time. So CDF of an exponential distribution is given by 1 minus e to the power minus lambda y. That's the distribution that you get. Fine. So now for the next part, so this will become 0 to z e to the power minus lambda x minus e to the power minus lambda z dz. And I think there's a lambda missing here. So lambda and lambda here. So this is 1 minus e to the power minus lambda x minus lambda x e to the power minus lambda z. So it's just algebra. There's nothing much over here. This is just algebra that I did. So this is your distribution for f of z. So now if I have to check if I did it correctly, what will I check? How can I check? If you're not following it closely, that's the thing I'm seeing. Because I made a few errors here. It is not x, but it is z, but you didn't tell me. So second integral is independent of x and so on. Fine. So now first tell me what will be f of fz of infinity. What should it be?
1.
1. Good. Z must be less than infinity is the probability should be 1. So let's put this value at infinity. It will get 1 minus e to the power minus infinity minus z by e to the power lambda z. Limit z tends to infinity. By L'Hopital, this goes to 0 again. So this is equal to 1. That is fine. Even at 0 also, this goes to 0. Probability of 0. 1 minus e to the power minus lambda into 0 minus 0. This is 1. Because z has to be greater than 0, which this also makes sense. Fine. So we found out the distribution of z. How do we find out the CDF or the the density? ddz of f of z. So tell me what will it be? E to the power minus lambda z minus e to the power minus lambda z plus lambda square z e to the power minus lambda z. Clear? This is how we find out. So any questions regarding how we formulated? So the integral and all, I know all of you can do it, but any questions regarding how I formulated the integral? Anyone? No doubts? Okay, fine. So now we'll come to joint distributions again. So again, very simple. I'll just do it for one of them, and you can similarly do it for this is your homework. You can try it out for the PDFs because I already did it for the joint and independent. So let us do it for conditional distributions as well. Okay, so we have to say that what is a conditional density and a conditional distribution. So again, recall that a conditional distribution is, or a conditional event is, probability of A intersection B by probability of B. Okay, so now I am telling you, I have to find out the conditional function itself. That is f of x given y. Say y is given to me, then what is the probability that x is some value, right? So let's try to find it out. So tell me, what will this be? So this is the definition of the conditional distribution. This is the conditional CDF. Is probability of x less than x given that y is less than y. This is the definition that we'll be using, right? Same, again, the same thing that I'm trying to do. There's nothing very difficult over here, right? So this is like, since it is a conditional distribution and since it is a CDF, I take all the events up to x and all the events up to y. So now this can be written as the set. What can this be written as? We already did it once just now. Probability of y inverse of minus infinity to y. Yes or no? What is the numerator again? Probability of x less than x, y less than y. Denominator is probability of y less than y. Fine. So what is the numerator now in terms of CDFs? This is the joint CDF. And the denominator is the marginal CDF. Is this clear to everybody? Clear? Any doubts? Any questions? We'll do a question with uniforms and then you'll understand, but please do it for all the PDFs as well, because it's exactly the same that we did in the previous question. So, okay, let's take an example and compute all these properties that we discussed just now. So the example says that you have a area given to you. The area is of this form. It's a semicircle that is given to you, that is x squared plus y squared less than equal to 1. Right? And it's told that this area is uniform. So the probability of selecting a point here is same as probability selecting a point there. So first of all, it has been asked for you to find out the joint PDF. So anyone who can help me with the joint PDF, what condition should I use to find the joint PDF? That's the question that I ask. So I have to answer P of x comma y is something between x squared plus y squared less than 1, x comma and y greater than 0, and 0 otherwise, which I can clearly see in the diagram. Can you tell me? How do I get it? What is the condition to get it? First of all, I said it should be a constant because it has told its uniform density, right? And I want you to find out what is the value of the constant. How can I find it? If you're following, what should I do?
I should integrate.
Integrate x comma y. In which region? X squared plus y squared less than 1 and y greater than 0. Yes or no? And that should be equal to by total probability. Good. But do I really need to compute this integral using radial coordinates and some things like that, which is not required here? I can clearly use the formula of an area of a circle, which is pi into 1 square by 2. Yes or no? It's a semicircle. Correct? This is C, so into C, this is equal to 1. So C is equal to 2 by pi. Is this clear? Two by pi. So clearly, if you integrate 2 by pi out on a semicircle, you will get 1. Okay. So now I found out the value of the joint. Now I'm asking you to find out what is the marginal distribution of x. Fx of x. What is the value of fx of x? Can you tell me what will I integrate this over to find the marginal? I've already discussed. Recall. So if you have to find probability of f of x comma y, the joints, do you agree if I integrate over all y, this will be equal to f of x? Because I'm summing over all possible combinations of y. Just like in discrete random variables we saw, x is equal to j, comma y was equal to x equal to j. Yes or no? Yes or no? This is fine.
Yes.
So now tell me what will be this integral? So between I will integrate it over all the values of y. Yes or no?
Yes. From 0 to 1.
Now tell me if for a particular value of x is given to me. So what are the possible values of y? X square plus y square has to be less than 1, right? This region must be always true. This region must be always enclosed. You must always be enclosed in this region. We cannot go out of this region because the probability outside is 0. Fine. So now if the value of x is given to me, y is just 1 minus x square, right? Since y is greater than 0. Y is given to be greater than 0. I can see it's above the x-axis. Is this fine? So I can just integrate y between 0 and root over of 1 minus x square. So the point I'm trying to convey is the integral can be a function of the other random variables as well. So now I can integrate this between 0 and 1 minus x square, 2 by pi dy. This is nothing but 2 1 minus x square by pi. Is this fine? This is your did I do something wrongly? Okay, so this is f of x of x. This is the marginal over x. Now I ask you this question. First of all, is this clear? Or is there any problem with this? I think there is a slight error there. So this is fine. Absolutely okay. Great. So this is the marginal distribution. We have found out the marginal distribution. So now next, so the integral limits are okay. Any questions? So next is you have to find out the conditional distribution of y given x. So you have to find f of y given x. So what is this going to be? What is this going to be? So what is the formula of the conditional we just derived? Right? The joint by the marginal. Yes or no?
Yes.
So I can put the numerator is 2 by pi and the denominator is 2 by pi into 1 minus x square. This is equal to 1 by 1 minus x square. So you see that x is given to me. Y given x is some value x is given to me. So this function that I have over here is a function of x. So can you tell me something but just seeing and hello, can you hear me? That's my
Yes.
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 I was not audible for some time now.
Yes.
Oh God, what is happening? Okay, that's great. I can at least. I hope we have not stopped recording. I think my screen is not visible. Just to give me a moment.
Yes. Screen is not visible.
Finally, I'm able to join. I think there was a problem with my computer network. Sorry. Now I think you can see my screen. Fine. Where did I lose you on the call? Can you tell me? Hello, am I audible to you now?
It's
Yes,
something to
yes.
observe from if y given x, you were saying.
Okay, fine. I'll start from there. Okay, so something to observe that given, see the right hand side here is this graph that is given to me. So given this x, so when a x is given to me, you can see this is a random variable. I'm trying to find out the density of y. X is already given to me, right? So, but you see there's no term in y here. Does this remind you of something? And if I just integrate over all y's from y equal to 1 to root over 1 by x squared, 1 by root over of x squared dy, what will I get? 0 to 1 minus, yeah. So this is a
1.
constant. Good. So what does this mean? It means that it's a uniform distribution. As we have seen, we had seen that y uniform 0, 1, we had seen uniform AB. So this is uniform 0, 1 minus x squared. So the way thing to understand over here is given x, y is a uniform distribution. So that is a very nice intuition to have over here. So we'll see now what is the expected value of and all these things. But before that, so even without seeing what is the expected value, can you tell me what will be the expected value? I will come back and solve it again. But what should be the expected value of y given x is equal to x? It's just a trick. So since it's a uniform distribution, it has to be between 0 and 1 minus x squared, right? It has to be exactly in the middle. So it should be 1 minus x squared by 2. So we'll come to it again. But if you remember, form gives us this this expectation or expected value. Fine. So now let's solve a question for multivariate or multidimensional lotus. So we have seen last time. So recall that the expected value of a random variable over a random variable x, g of x is a function. So what is this? By lotus for a single random variable. This is the integral of g of x, the density of x, dx. Yes or no?
Yes.
Fine. So now we are saying that we will do it for a joint. Similarly, so it can be any function of the two variables. So what will it be? It will be again similarly f of x y, very similar, just analogous equation I'll write dy dx g of x comma y over all x and y. Fine. So then now if you have understood this, let us try and solve this question. This will help you to appreciate the multivariate lotus a bit better. Okay, so I'll copy this. Fine. So now I want to find out the distribution of x minus y whole square, probably, most likely. Let me just check. Yeah. The expected value of the distribution of the function x minus y. So now first tell me what is the joint. Both x and y are told to be uniform 0, 1. So what will be the joint? Can you tell me? If x and y are between 0 and 1, 0 otherwise. So again, if I consider this area to be C, what is C going to be? C times the integral of f of x. It's a uniform distribution, right? So f of x dx dy integral of 0 to 1, 0 to 1, this is equal to 1. So C is equal to 1. Is this fine? It's the square, right? The
Yes.
area under which I am trying to get the expectation is a square. Yes or no? Of length or both length and width to be 1. Vertex length 1. So now I'm asking you, can you find out the distribution of x minus y or the expectation of x minus y whole square? So what will I write this as? Tell me. What will it be? X between 0 and 1, y between 0 and 1. For every x, you will go to between 0 and 1, right? This is how you calculate multivariate.
minus
thing.
y
Yeah, correct.
dx dy. C times x minus y squared dy dx.
I couldn't hear you because my mic was, I think, disconnected. Is my voice here
No, your voice is a little off.
now also?
Yeah, I think your microphone is a bit away.
Okay. Can you hear me now? I think I was not able to even hear you. That's why I was asking. Fine?
না দাদা
Just let me know if it is not fine, because all this recording will be a problem then.
It's a bit low. It's a bit low.
I'll just try. See this. Okay. Just let me know if you cannot hear me. I'll just get it right and change. Sorry for the hassle. So yeah, let's try and do this for x and y. I'm just using the 2D lotus. The joint is just 1. Joint distribution's density is just 1. So I'll just integrate over y. What will this be? Y minus x minus y whole square whole cube by 3. Y between 0 and 1. So what is that? That is x minus 1 whole cube minus x cube by 3. Yes or no? Is this fine? I hope this is fine. I just integrated this out. X minus y. I think I did something, a little bit of a mistake. We didn't check. So I'm integrating it over with respect to y, but it is minus y here, but yeah. So it should be a negative of this. Yes or no? Yeah, should be just the negative of that. So this is between 0 and 1 and 0. Now I'll replace the values. So it's between 1 and 0. So fine. So now once I put this, now again I'll integrate out x. I'll get minus x minus 1 to the power 4 by 12 and minus x to the power 4 by 12. This is between 0 and 1. This plus just check the calculations if I am doing it correctly. So I'll put value of 1 and this goes to 0, 0, it goes to 1 by 12 plus 1 by 12 minus 0. This is 1 by 6. Fine, calculation is fine. The expected value of 1 minus x minus y is just 1 by 6 over here. I'll just wait for a moment before if you have any questions or anything to talk about the calculation. Otherwise,
I think like you took the bracket wrong, right? The bracket would have included the minus as well.
really, which bracket, the first one or the second?
I mean,
yeah, this would be minus. You are saying?
Yeah.
That is true. I think this is correct. It's fine. I think I still got the by chance I got the answer right, isn't it? By chance I got the answer right.
Yeah. Yes.
Yeah. I just did 2 mistakes. Fine. Sure. So we understood how to use the 2D lotus, and now What is left now is the final thing of the class is today. Last 20 minutes I'll do with what is called conditional expectations. So conditional expectations is what we'll be using for most of our algorithms in reinforcement learning. So how do you interpret what is a conditional expectation? So a little time ago, I showed you that x, the y given an x, was a random variable itself in terms of x. So again, expectations of y in terms of x is again a random variable. What I'll show you why that turns out to be true, but the intuition is something like this. So you recall that expected value of y or some random variable x was just x, just recall, into x being small x for all values of x between z minus infinity to infinity. Right. So this was your expected value of for a random variable x. So now I tell you that I am giving you. So I am giving you a random variable y. I'm giving you a random variable x. Please find the expectation of another random variable y if x is known. So this is what the intuition of a conditional expectation is. We'll see what does this actually mean in terms of a function, but this is what the definition is. So just analogous to any other probability distributions, we can write the expected value of x given y or y given x in our case to be the same thing. So we are trying to find out here the expected value of y. Remember, expected value of y is what we are trying to find. What is given? Given is the random variable x. So if you have any trouble while working with these problems, always think that this is a constant. This x is given to me, say small x. And at the end, we will replace x with the parameter x with the random variable. So let's see how to do that. So now, since this is given to me already, I can again write probability of y equal to y equal to 1 or minus infinity to infinity. But I have to take into account that x is given to me. So I use the conditional distribution. So I use the conditional distribution to define the probability. So since x is given, to find out the expected value of y, I use the conditional distribution of y given x. P of y given x is what I try to use. So this is how the conditional distribution, the conditional expectation is defined. So there are more complicated definitions of the conditional expectation, but the idea is how does a random variable x influence the expected value of the other random variable? So let's take an example and try to understand. So I'm trying to find out the expected value of x, the same problem that we discussed just now, y given a random variable x. So now whenever I told you we have to find it in terms of another random variable, what did I tell? You assume the other random variable to be a particular form. So let's take that. So for finding this, we'll find probability expected value of y given x is equal to 0, right? If x is given to be 0, so what can I write this as? Y equal to 0 and 1, probability of y equal to small y given x equal to 0. Yes or no? Do you agree? This is fine.
Yes.
So we have okay. So we have already found out that the conditional probabilities have already been found out. Can you recall? Can you give me the numbers if someone has it noted down? X equal to 0 and probability of y equal to 0 given x equal to 1. Both these numbers. I think the first number was half. Let me just check. Yeah, x given y. I think it was given y. Sorry, it's fine. Did I find the expected value of x given y or y?
I think there was a mistake there, like on my part. So I did the opposite thing. So expected value of, I mean, the probability of y given x would be half.
Ah,
And
I
it
see.
would, for the other way around, it would be 2/3 and 1/3. So I just want to point out now that it's wrong.
So in the previous one, right?
Yeah, here.
Here, so we were trying to find out x given y.
Yeah, so for x given y equal to 0, it would be 2/3. For x equal to 0 and x equal to 1, it would be 1/3. It was wrong.
Yeah, it's fine. This is right. So this is this should be x equal to 0. Fine, right? You're right. So I think we were finding y given x or x given y. I don't remember, but x given y only we found. So this should be y equal to 0. So it's fine. It doesn't matter. So we'll put the other way around. It will help in our calculation. Fine. So this is same. This will still remain the same, right? The answer yes. No. Now this is denominator is x equal to 0. Correct. Fine. This is fine. Correct. This is also correct now. Now y equal to 1 given x is equal to 1. This denominator is x equal to 1. So right. So 3/8 by half. That is 3/4. Yes, yes or no?
Yes.
So if there are any calculation errors due to this, please correct them. So it's we'll just x is equal to 0 given y equal to 1 is 1/4 and 3/4 respectively. So y equal to 0 is half and half, and this is x is equal to not y equal to 0. Sorry, x is equal to 0 and y equal to 1. Fine. Half and half and 3/4 and 1/4. Fine. Where is it? Yeah, here you go. So y equal to 0 given x is equal to 0 is half. Similarly, y equal to 1 given x is equal to 1 was half as well. And probability of y equal to 0 given x is equal to 1. This was 3/4. And probability of y equal to 1 given x is equal to 1 is 1/4. Was this
Yeah.
the thing?
Yeah, in the left you have by mistake written y equal to 1, x equal to 1, and it would be y equal to 1, x equal to 0.
Correct. For the y equal to 0 is 1/4, no? I think we calculated the other way around. This is fine. Let's check it once. Just bear with me for a moment. I just can't find it exactly. Yeah, here you go. So yx is equal to 0 given y equal to 1 is 1/4. And 1 is 3/4. This is fine. Okay. So this is y given x is equal to 0. This is equal to, can you tell me? So this will be y value, y is equal to 0 into probability of y equal to 0 given x is equal to 0 plus 1 into probability of y equal to 1 given x is equal to 0. This is 0 plus half into 1. This is half. Half is the expected value. Similarly, expected value of y given x is equal to 1 will be 0 into probability of y equal to 0 given x equal to 1 plus 1 into probability of y equal to 1 given x is equal to 1, which is 3/4 again. Is this clear to everybody? Fine. So now let's see you check a couple of properties. Before checking that property, let us find out the question that I asked you. So f of x given y was uniform, or rather y given x was uniform 0, 1 minus x square. Right? So now I asked you what is the expected value of y given x. So what will it be? How can I write this? Previous problem. Can you tell me? Not difficult. So what do I do? Y again, f of y given x dy. Yes or no? Correct? It's given to me. Uniform 0, x 1 minus x square. So this is 1, right? So this is the integral of y dy 0 to 1 minus x square. This is y square by 2, 0 to, sorry, this is not 1, this is 2 by pi, if I remember correctly. No. What was this? Just let me check. This is 1 by 1 minus x square. Yes or no?
Yes.
This is the one, this is the CDF. So this is x square. This is 1 minus x square by 2 into 1 minus x square. This is 1 minus x square by 2. So this is what I was trying to tell you. Just see. Y given x is the half. So if I just drew this circle for a given x, right? The y value would be up to 1 minus, the y would be distributed as uniform 0, 1 minus x square, right? So now I tell you, if I have to find out, because x is already given to me, the expected value of this uniform, where will it lie? In the midpoint, right? It will lie exactly in the middle. That's exactly what we got here. Is this clear to everybody? So it's like, see, what does it, do you see that given x, this is a random variable. So now we had, for this, especially this question, we had selected a particular x, and this turned out to be 1 minus small x square by 2. But for any general x, do you agree that y given x, when I observe it, is 1 minus x square by 2? So this is where the feel good factor comes in. See, the expected value again turns out to be a random variable, doesn't it? Because it depends on x. Yes or no? X is a random variable again. Conditional expectation is a random variable. Just any questions? Is this fine? I can explain again because we're okay. So because we're at the end, there's only one question left before we stop. So if there are any other doubt for others as well, please stop me and ask. So fine. So this also we have done for continuous random variables. So we found out expected value of y given x is can be a function of a random variable. Some say g of random variable. So this is so it's a function of a random variable. Variable conditioned on. So this is the function of the random variable we're conditioning on, just like we saw 1 minus x square by 2. So okay, so now two very important properties of conditional distributions. Expectations is known as iterated expectation and pulling out what you know. So now if I ask you, tell me the expected value of x is actually a double expectation. First in terms of x given y and then in terms of y. So first I select y. I do a sampling and then find out the expectation for that. Sorry, no. I find out the expectation of yx with respect to that y, and then take the expectation with respect to y again. That gives me expectation of x. So let us try to find out, understand what is this. The expected value of, first tell me what is the expected value of x given y. This is x f of y xy dx. Yes or no? This is fine. This is the expected value definition. This is the conditional PDF. I'm assuming it exists, but yeah, fine. So now I tell you, so now this has to be a function of, this is a random variable of which, of what random variable? This is the function of which random variable? Can you tell me? So we are pulling out x, integrate. Yeah, tell me. I couldn't hear you, Antariksh.
It's a function of y, right?
Yeah, it's a random variable of y. The random variable of function as a function of y. So you see, so this function, I can write this as some function g of y, because I will not have x is being integrated out. So this expected value of x given y can be written as expected value of g of y. Yes or no? I just took this, since it is a function of y, I took that value. This can be written as integral of y g of y dy, y equal to minus infinity to infinity. Yes or no? And I just put the definition of y back in this integral. This is minus infinity to infinity, y integral of x given y, xy dx dy. Is this clear to everybody? Any question? Sorry, again, f of y. Again, if I am making these errors, please tell me. So it's again lotus. Expected value of a function is the expected value of, is the integral over that function for the PDF. Fine. Any questions? Okay. So now I can write this as two integrals, minus infinity to x, minus infinity to infinity, sorry, and then x fx of y, x y dy dx. I'm just reordering the integrals. I can do that since the integrals are exist. I'm assuming the integrals exist. So now say this is an integral over y. I can pull out x. So did you understand? I use this property f of y into y given x is nothing but the joint distribution. Yes or no? The conditional, that is y given x is equal to x comma y by x. Whatever I'm writing here is it clear?
Yes.
Fine. So now I just multiplied the marginal with the conditional and I got the joint distribution. Again, I pull the x out and I integrate x to y dx dy dx. So what is this going to be? We have already defined this before. This is going to be
The marginal with respect to x.
very good, because we are integrating out y. So this will just be the marginal with respect to x, which is the expected value of x. Is this clear to everybody? Fine. So I can clearly see.
Yes.
So First, the idea is first, I'll do an example and it will be clear. First, condition on a random variable y, find the expectation. So steps are this: find expectation in terms of function of y, and number 3, use lotus to find expected value of x. Good. So this is iterated expectation. The last thing is, if x is already given to you, I say that y into g of x is same as pulling out g. First, can you tell me the intuition of this? Anyone with the intuition? So see, x is already known. Yeah, tell me.
Yeah, so the conditional probability would be a function of x, right?
Yes,
So we can then use lotus again.
correct. So exactly. So the y g of x given x can be written as the integral of minus infinity to infinity y g of x, x of f of x, f of y given x, x comma y dy. This is fine. Again, lotus. This is the function, and this is the density. This is lotus. So now, since it is lotus, can you tell me what is the integral over? The integral is over y, right? So I can pull out x. Yes or no? Any questions? Fine. Everyone. So as Antariksh was telling me, this is a both are functions of x at the end of the day. So I can take a product of the functions of x. Or you can think of it as, since x is already known to me, this is a constant for the expectation. So I can take it out of the expectation. Fine. So let us take the last example and finish the class. This will make you appreciate the need for using iterated expectation. So say at every step you toss a coin, and if it is a success, in the restaurant you can place an order. And once you place an order, so you toss a coin. If it is head, you place an order, and you get after exponential lambda. If it is a tail or a failure, in this case, you have to wait again for exponential lambda, and then go back to ordering. Okay, this is given that the probability of success is p, and the time for food to arrive is distributed as exponential lambda. So now I have two problems over here. So the first thing is, so I toss the coin, say x1. If I get a success, right, I will get food in terms of x1 itself. So let's say x is the time, or did I use, no, t is that, let's take t. t1 is the time for first exponential lambda time period. That is before you can reorder or get your order. So say that you did not get your order. So then what will be the total time? Say here you did not get. So your total time becomes t1 plus t2. Yes or no? Because now t2 again toss the coin. And so on. So this will go on till t1 plus t2 plus dot 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 tn. This is total T, where n is distributed as geometric P. Why did I say geometric P? Can you tell me? Tosses to get first head, and Ti is exponential lambda IID. So now, if I just gave you this and I told you to find out expected value of T, could you find it directly? Is my question. You can't find it directly, right? Because why? Can you tell me? Because this n is not known, right? So say first toss was fail, second toss was a failure, dot dot dot, nth toss was a success. Only when the nth toss is a success will you stop. So say I tell you, if I already knew n, would your problem be solved? Yes or no?
Yes.
If say I knew that n was equal to small n, then I could have written as this as summation of I equal to 1 to n Ti. I could have done this very easily. So now this I could write this as by linearity of expectation I equal to 1 to n expected value of Ti. This is equal, the expected value of an exponential is expected value of exponential lambda, we did it last time, is 1 by lambda. The
1 by
faster the parameter, the faster it arrives. The larger the parameter, faster it arrives. So it's like n by, so we see that expected value of T given n is equal to small n is n by lambda. So, but observe one thing, again, it's a random variable, right? I can just remove small n and write expected value of T given capital N is n by lambda. Yes or no? Fine. So now I have to find the expected value of T. What can I do now? To find expected value of T, I can just take the expectation of this function of n. Yes or no? Which is expected value of n by lambda. Fine. Which is expected value of n. Lambda is a constant. What is the expected value of n of a geometric? We found out in the first class. So if probability of success is 0.5, how many trials will you need to get the first success? That's the is the hint.
2. I mean, it would be 1 by P, right?
Yes, 1 by P. So this is your expected value, expected time. So this is why you need iterated expectation. Sometimes the sum can be convolutedly determined by other random variables, which is not known to you. And then to find expectation on any statistic of the data, you can't find it unless you assume one of the variables to be known. So that's why you need iterated expectation. I think with that, we'll stop today. If you have any particular questions, you can ask me. I'll stop recording. Anyone, any questions? And we'll start with reinforcement learning next day. So please tell all your friends who are thinking that they know probability. We'll get started with reinforcement learning next day. We are done. Once we get into reinforcement learning later, a few 3-4 classes, we'll also come back again and do Markov chains. But other than that, I think we are good to go. If you can solve the questions that I gave, it will be a good exercise before we start reinforcement learning. So any questions you want to ask
Dada,
before I
next
stop?
next class.
Next class is on, so that we'll discuss, but yeah, any question related to the topics we discussed today? Any doubts? If there are none, I'll stop recording. Okay. Fine. Now next